Solution. My topic is RISC architecture. Here is the introduction about the RISC architecture. Here RISC stands for Reduced Instruction Set Computer. This emphasizing simplicity and the efficiency. The architecture is designed to execute a small set of instructions quickly. This is used to execute the small set of instructions very quickly. This processors typically have a large number of registers to optimize performance. Here is the data part, data cage, then the data path to the hard drive, the control unit, then into the instruction cage, then the main memory. This is the RISC architecture. This is mainly used to design and execute a small set of instructions very quickly. There are the key principles of RISC. The RISC architecture is built around a load store model, separating memory access from arithmetic operations. Instructions are fixed length, simplifying instruction, decoding, and pipeline design. This emphasizes a large number of addressing modes, making instruction execution more predictable. Here are the advantages of the RISC architecture. There are advantages of this architecture. They are reduced instruction complexity allows for faster instruction and execution. The simplicity of the instruction set improves the efficiency of the compiler. RISC designs often achieve better performance due to efficient pipelining and parallel execution. Here are the differences between RISC and RISC versus SISC. SISC or stands for Complex Instruction Set Computer that offers a large number of instructions compared to RISC. This RISC focuses on executing instructions in a single cycle, while SISC may take multiple cycles. RISC systems often achieve higher performance in applications requiring speed and efficiency. Here are the differences between SISC and RISC. SISC emphasizes on hardware. This emphasizes on software. SISC, multiple instruction sites and formats. In RISC, instructions of same set with a few formats. In SISC, there are less registers. In RISC, you use more registers. In SISC, more addressing modes. In RISC, fewer addressing modes. In SISC, extensive use of microprogramming. In RISC, complexity in compiler. In SISC, instructions take a varying amount of cycle time. In RISC, instructions take one cycle time. In SISC, pipelining is difficult. In RISC, pipelining is easy. These are the differences between SISC and RISC. Here is about the pipeline architecture and RISC. Pipeline allows multiple instruction phases to be executed simultaneously for increased throughput. RISC architectures are designed for deep pipelines, enhancing instruction level parallelism. Effective pipeline implementation reduces the number of clock cycles per instruction. There are some segments for pipeline architecture in RISC. They are fetch instruction from memory, segment 1. Segment 2, decode instruction and calculate efficient address. This is segment 3. The branch, fetch operand from memory, then execute the instruction, then interrupt. Then the segment 4, interrupt the handling, update PC, and empty file. This empty file will fetch instruction from memory again and the process will be continued. A register usage in RISC. RISC architectures typically have a large number of registers than their SISC counterparts. The extensive use of registers minimizes the Need for memory access, improving speed. Register-based instructions reduce the complexity of operations, contributing to overall efficiency. Here are the differences of CISC and SISC. In CISC, emphasizes on hardware. RISC emphasizes on software. In CISC, multiple instruction types and formats. There are less registers, more addressing modes, extensive use of micro programming. Instructions take a varying amount of cycle time. Pipelining is difficult. Whereas in RISC, emphasis on software, instructions of same set with few formats, uses more registers, favor addressing modes, complexity is in compiler, instructions take one cycle time, pipelining is easy. Here are the examples of RISC architectures. Popular RISC architectures includes ARM, MIPS, and PowerPC, each with unique features. ARM architecture is widely used in mobile devices due to its energy efficiency. MIPS architecture is often used in embedded systems and academic settings for teaching purposes. Here there are the types of RISC architectures. IF means instructions fetching. ID means decoding fetching register fetch. EX means executing the address. MEM means memory access. WBAC means write back. Here you can see the diagram of the RISC architecture. RISC in modern computing. RISC principles have influenced modern computing, including the design of GPUs and specialized processors. Many smartphones and tablets rely on RISC-based processors for optimal performance and battery life. The rise of RISC-V is shaping the future of open source hardware design and innovation. This is a pipeline architecture in RISC. Pipeline allows multiple instruction phases to, to be executed simultaneously for increased throughput. RISC architectures are designed for deep pipelines, enhancing instruction level parallelism. Effective pipeline implementation reduces the number of clocks per instruction. Here is some segments. In segment 1, fetch instruction from the memory. In segment 2, decode instruction and calculate efficient address. In segment 3 and segment 4, branch is fetch operand from the memory and then executing the instruction. Then it will interrupt the handling, then update the PC in empty pipe. Then again go back to fetch instruction from the memory and the process will be continued. RISC in modern computing. How RISC is used in the modern computing? RISC principles have influenced the modern computing, including the design of the GPUs and specialized processors. Many smartphones and tablets rely on RISC based on processors for optimal performance and battery life. The rise of RISC shaping is the future of open source hardware design and innovation. Challenges facing RISC architecture. As software complexity increases, the simplicity of RISC may not always meet all performance needed. Managing power consumption while maintaining performance is an ongoing challenge. RISC architectures must adapt to emerging technologies such as quantum computing and AI. This is some differences between SISC and RISC. In SISC, emphasize on hardware, multiple instruction sizes and formats. There are less registers, More addressing modes, extensive use of microprogramming. Instructions may take a varying amount of cycle time. Pipelining is difficult, whereas in RISC emphasizes on software instruction of same set with a few formats, uses more registers, favor addressing modes, complexity in compiler, instructions take one cycle time, pipelining is easy. Challenges facing in RISC architecture. As software complexity increases, the simplicity of RISC may not always meet all performance needs. Managing power consumption while maintaining performance is an ongoing challenge. RISC architectures must adapt to emerging technologies such as quantum computing and AI. Future of RISC architecture. The future of RISC architecture looks promising with ongoing developments in RISC-V. Innovation in chip design are expected to enhance performance while reducing power consumption. RISC will always continue to play a crucial role in evolution of computing and embedded systems. Thank you.